Homework Hotline, what is your emergency?
Hello, thanks for tuning in to the Homework Hotline. I'm Becca, a math teacher at Emily Griffith High School.
Welcome to the show. I'm also a math teacher at Emily Griffith High School, and my name is Nathan.
So Nate's back today. Sam is out for today. When do I get a day off?
I don't know. Who says you get a day off ever? I mean, it's your birthday today, and you don't get the day off, so.
Hey, don't tell everybody that.
Oh, sorry. Secret.
Ah, darn.
So do your math questions or math or science questions have you scratching your head? Give us a call. Becca and I will be answering your math questions today.
You can watch our show in several different ways. So for live broadcasts, you can watch us on Comcast Channel 22 or go to livestream.com and search for EG Homework Hotline. But if you'd like to see some of our past shows, you can watch us on YouTube by searching for DPStv Homework Hotline.
And the Homework Hotline is sponsored by Contemporary Learning Academy and Emily Griffith High School. One of our Emily Griffith High School students, Lily, is also part of our team. Lily, why don't you tell the audience a bit about yourself and what you do here on Homework Hotline?
Hi guys, I'm Lily and I am a senior at Emily Griffith this year. And also the Homework Hotline wants to be accommodating to those of you who like to turn in your social media or your questions on social media. And I help get those questions over to Nathan, Becca, and Sam when he's back. And also, I am the trivia queen, and at the top of each show, I will ask you, the audience, a trivia question, and before the end of this show, I want to hear the answer from you guys. The trivia question can be on any subject, but today it's a question about languages. And the trivia question is, after Chinese, what are the world's 3 most commonly used languages? And we will get back with you about that at the end of the show.
Ooh, awesome. That's a good trivia question today. So if you have an answer to that, or if you have any homework questions that you would like some help with, the phone number is on the top of your screen. We'll be here till 5:30 to answer those live, or you can give us an answer for the trivia question. But you can also get a hold of us in several other different ways, including social media, as Lily mentioned earlier. So you can send your questions in on Facebook or Twitter at EG Homework. If you'd like, you can text your questions at 970-680-3771, or you can even email us at homework@emilygriffith.edu. So you've got a lot of ways to get in contact with us. We do prefer phone the most because that way we can make sure that we're helping you and we can interact with you and make sure that your questions are being answered, but you've got some options. So get a hold of us before 5:30 and we'll answer some questions for you. Let's go into Lily, go check in with Lily and see what social media questions at the moment we have.
This one asks, -10 plus 19b equals 7b plus 2. And they asked to solve for b.
I can take that one, even though it's an algebra
Part of the
question.
issue with that one is that there are variables on both sides. I think that's one of the difficult issues with that.
And I think that throws everybody off at the beginning. But with this, really, you're kind of doing the same thing. You're just isolating the variable b. But like Becca said, the challenge is that there are variables on both sides. So we can actually do this a couple ways. But ultimately, you kind of want to combine like terms. So what I'm going to do is kind of look at my like terms and think about what I can do to combine, for example, 19b and 7b. So what I'm going to do first is I'm just going to, move this over to the other side. I'm going to take this out, do the inverse operation to subtract 7b from this side. Keeping in mind when we talk about equality, we have to do what we do to one side of an equation, we have to do to the other. So I'm going to do that over here. And that kind of resolves the issue of the variable being on both sides. So I like to go through these kind of step by step and avoid making mistakes. So I'm going to copy everything else over. 19b minus 7b is positive 12b equals, and then we come over here, 7b minus 7b is going to be 0, so these are going to cancel out. That's kind of the goal here, and that's going to equal 2. So we're still doing this thing where we want to kind of combine our like terms. So I'm going to now add 10 to this side because it's going to cancel it out. Do the same thing to this side for equality, and these cancel out, and I'm left with 12b equals 12. So the last step here is, again, I want to isolate my variable b. So if I have 12 times b, I need to do the opposite. So if we have multiplication, right, the opposite of multiplying is going to be division, or the inverse operation. So if this is 12 times b, I'm going to go ahead and divide. And that cancels out my 12, and I get b equals 1. So that would be your solution. The good thing about these problems is if you're ever not sure if you did it right, you can just check your answer really easily. By what we're saying is, if b is 1, this side of the equation here should be equal to or the same as this equation here. So if I want to just double check these, all I'm going to do is plug in 1 for my variable. So plus 19 times 1, and that should be the same as 7 times 1 plus 2. And I'll just check that really quick. Negative 10 plus 19 equals 9. And in this case, 9 does equal 9, so that worked out. So really easy to check these if you're ever doing your homework or just taking a test. You can always be sure that you got the right answer by just substituting and making sure that the statement is true.
Very nice. Yeah, those actually make me think of if you have a multiple choice test, when they give you questions like that, you could just even check all of the
That's a good strategy
choices.
if you just have no idea what to do, although we always try to avoid teaching that method, but a lot of students figure that out.
I know,
So.
I know. All right, well, let's go back to Lily and get another social media question.
So this one asks, what is the percent of change from 26 to 39?
Okay, so we're going from 26 to 39. Okay, so I can definitely help you that. So we're wanting to know what the percent change is. And when you do percent change, what you want to do is find, you really set it up in a fraction and then turn it back into a percent, actually. The way it works is this, is you find the difference between the first and second value. So I'm actually going to use this symbol just because I like it and I want to tell you what it means. So this symbol, delta, it means the change or the difference. So difference meaning how far apart they are. So the change from the first number to the second number. And we find the change in that over top of the original value, what we started with. So we're really thinking of it as a portion, as how much it changed out of the total that it started, and that's going to tell us the percent change. So when we find the percent change again, we're finding the difference between the first number to the second number. So we're going to subtract. So finding out how much it changed by, and then it's going to be out of the original amount. So over top of 26. So when we find that difference, so 39 minus 26, we have 13 out of 26. And this one I actually don't even need a calculator for, because 13 out of 26 is equivalent to 1/2, which in percentage is 50%. So from when you're going from 26 to 39, we're changing 26 50%. We're increasing it by 50% in order to get to 39. So percent change, if you can kind of remember this little formula, that's really how you're going to calculate it. And then you also just want to think of, is it an increase or a decrease? So hopefully that helps. All right, let's go get another social media question. Is that what's next on our
I think so, yeah.
on our list to do?
So this one asks, how do you find the circumference of a sphere?
I'm gonna let you have this since it's geometry.
Okay, so I'm going to actually give you probably an example, but the first thing you need to know is kind of the equation of circumference of a sphere. So if I have a sphere, it's kind of, if you go to my board here, I'm going to try my best to draw what it kind of looks like. All right, so it's kind of this three-dimensional shape, kind of. So the circumference of a sphere is going to be this equation, c equals 2 times pi times r. So all we need to do, and really just comes down to kind of plugging in information, is you need to first figure out what the radius is, and oftentimes this is going to be given to you, which is like the distance from the center of the sphere to the outside. So whatever this distance is here, that's my radius. So for example, if in this case my radius I'm told is 5, all I'm going to do is plug that in. C equals 2 times pi times 5, and then just simplify from there. So C is going to equal 10 pi. Depending on kind of what your teacher's asking, this is the most precise answer for the circumference of this particular sphere.
I like it that way.
I like it this way
I
because
always
it's,
tell them to
yeah.
give me that answer.
Because if you're not, then you're actually rounding, which means you're approximating, which isn't precise.
And
But
plus, to be perfectly honest, that's a lot simpler
it is a lot simpler.
anyways.
The only time I would probably recommend to go ahead and do the math or approximate is if you're talking about like an application problem, and then it doesn't make sense. Like if I have a basketball and I want to find that circumference, nobody's going to say it's 10 pi. Nobody's going to know what you're talking about.
Right.
So in that case, I would just go ahead and multiply 10 times pi in my calculator, and you'll get something like 31.41, and then round to whatever you need to.
Right.
But really, this comes down to knowing this equation, this formula for circumference of a sphere, and then being able to apply it.
Makes a lot of sense. All right, well, back to Lily, I believe, for another social media question.
These are quick today.
They are. I like it.
So we got a word problem here, and this one asks, there are 15 people in a room. Each person ate 2/3 of a pizza. There was no pizza remaining. How many pizzas were in the room?
Yeah, you love fractions. Do you want to take
fractions.
that one?
Yes, I love fractions. In my previous life, I was a middle school teacher, and so I just fractions all day, every day.
And as a math teacher, I pretend to love fractions, so.
Right, you pretend, right? I love it though because nobody likes them.
Right.
Nobody likes them at all.
Just you.
Just me. So I'm not going to actually draw this whole scenario, but what I do want to express is this. So the scenario, let me draw just at least one of these pizzas. So what they're saying is that there were 15 people in the room, and these 15 people, each person ate 2/3 of a pizza. So, and actually, let me continue with the picture, because to be perfectly honest, and I really do love fractions, I'm not gonna lie, I do, I think they're brilliant. I think they're a wonderful way to express parts of numbers.
It's true, she talks about it all the time.
I do, love with fractions. But let me, I'd like to maybe show what the pattern is with this and why the actual numbers in the math work out. So if each person ate 2/3, so I'm gonna color another, so there's 1/3, and there's 2/3. So that's 2 people so far. And then the third person, so here's another person, 1/3, 2/3. So what you can kind of see here is that if we had 2 whole pizzas, it's going to be 3 people. So 2 pizzas for 3 people. We have 15 people. In the 15 people, so we can break that down. So 3 people, that's 2 pizzas. 3 more people, that's 2 more pizzas. And here I'm going to say people. Maybe this is a good way to organize it. People and pizzas. So 3 people, 2 pizzas, 3 more people, 2 more pizzas, and so on. And we know there are actually, it's kind of a ratio question, another fraction. We know that there are 5 groups of 3 for the 15 people altogether. So there are also going to be 5 groups of 2 for our pizzas. So I just did this without doing any number calculation. I figured out that altogether they ate 10 pizzas just by drawing myself a picture. Now, if you wanted to figure this out mathematically, you can think of it this way. 15 people, each person ate 2/3. So that means there are going to be 15 groups of 2/3, which is kind of the same thing as multiplication. So 15 times 2/3. Mathematically, the way that we would do this, we would set this up as 15 over 1, which is the same thing as just 15, and multiply across and simplify. So 15 times 2, 30. 1 times 3, 3. 30 divided by 3, or simplifying that, also gets me 10 pizzas. So a couple different, I guess it's a couple different ways to think about it, but I really think and strongly believe that with anything fraction-based, a picture is worth 1,000 words. I mean, not to be cliche, however, they really, really can help you understand what to do in the problem, and also help you figure it out, and also make sense of just what fractions are and how they work and things like that. So 2 different ways to solve the problem. Hopefully that helps. I've got a lot of fraction tricks. If you've got questions, I can definitely help with those.
I like that you showed it visually, because I think a lot of students have trouble with fractions because they learn it in like the 4th grade, and they don't really understand what they're learning yet.
Right.
It makes so much more sense when you're a little older and you can kind of grasp the concept.
The concept of it and what it is physically. Like 5/9 of something, that just sounds like, well,
right.
What is that even? But if you can picture it, it makes it make a lot of more sense. So. All right, if you're just joining us, so you might be just getting home from work, sitting down with your after-school snack, and maybe you missed our information. What we do here is we answer homework questions. So if you're sitting down, getting started on your homework, something's stumping you, especially the math, Nate and I have got you. You can give us a call until 5:30 and we'll help you answer those homework questions live. Other ways you can get in contact with us if you missed it before. The phone number's up there on the top right of your screen, but you can also send questions in through social media at EG Homework. You can text us at 970-680-3771, and you can also email us at homework@emilygriffith.edu. So if you're just sitting down, getting ready to start that homework, give us a call.
We're going to go back to Lily for one more social media question before we go to commercial.
This one asks, the tables at a party are shaped like a hexagon. 2 people can fit on each side of the table, and if you put the tables together, how many would you need to seat 50 people?
Okay, I can take that one.
Okay, that's an interesting question.
Yeah, it is. I'm trying to draw a hexagon here, actually. So a hexagon has 6 sides. So you know what? I'm not even going to bother trying to draw this because it's going to look really bad. I'm going to go ahead and pull up a picture of a hexagon.
Just steal it.
Yeah, it's always easier that way. I'll give proper credit, so. Let's see. So I'm actually just pulling up a picture of a hexagon really quick, so it will look a little bit more clean. All right, so we got a hexagon. A hexagon has 6 sides to it. The question here, and I'm not really clear, maybe you can give me your interpretation, Becca, is...
Lily, could you go back to the question? Okay.
It says they're setting the tables side by side, so they're connecting them. So we said the tables at a party are shaped like a hexagon. We can fit 2 people, so we'll say these are my people. This is why I'm not drawing a hexagon, on each side of the table. But the trick here is we're saying if you put the tables together. So I'm assuming we're kind of just putting them together kind of like this.
I'm going to do something on my thing too.
Okay. So this would be 2 tables. This is my assumption. You could squeeze another table in here, but I'm not really sure if I'm interpreting the question correctly.
Well, maybe.
Are we just going side by side,
Yeah,
you
I
think?
think, well, let me look at it one more time at the wording. 2 people, if you put the tables together, how many would you need to seat 50 people?
Yeah.
Well, let's look at it this way. So let's say you had the 1 table. How many people can you fit on it?
So 1 table, it's got, and I'll just write this down, you've got 6 sides, or you can write it down since it's up on your screen.
Well, I like the visual on yours.
Okay, so it has 6 sides, right? And you're fitting 2 people per side. So each one can fit 12 people, but when we put the table side by side, we're losing a couple spots, right?
So when you add a second table, you're hypothetically adding 12 more people, but not really, because on 2 of those sides, there's the 4 that's being taken away.
Yeah, so if we look at this
So
graphically, we're actually
almost like
only able
thinking
to
of this as
fit
plus
10.
12 minus 4. So, well, actually less than 10, because 2 of those hexagons are losing a side.
Right.
You know, if you think about it. So 12 and 12, when you put them together, the side that is merged, you now actually only have 8, right?
Or 10.
Or wait, hang on.
So we
12
have
and
6,
12.
we're losing one side, so we're not able to seat anybody here, right?
Right.
So that means
you're
we have
losing
1,
2
2,
people
3,
from
4,
the first
5.
table
And 2 people.
and 2 people from the second
but we're
table.
losing.
So 12 plus 12 minus 4, so 20.
Yeah,
So 10 people
because
on
we're
each
getting
table, you're
another
right.
table here. This
I
is why
like
my
this.
hexagons aren't very good.
I like this problem.
Yeah, it's
You
kinda
guys
tricky.
can also, I hope you're learning a little bit from the problem solving process as we're bouncing back and forth of how to potentially solve this problem.
And this is why we said, even for that last problem with fractions, it really helps to kind of draw this out and visualize what's happening.
See what's happening.
Yeah, because
exactly.
now I can kind of clearly see that I'm losing these 2 spots on the second table.
Yes.
So I'm actually only seating 8
So now we're
at the
seating.
second table.
Right. So, but when you have 2 tables, you have 20 people. Now when you
Right.
have 3
More.
tables, we have 10. I'm going to write this kind of.
So I'll write
Table
10.
1, there is 10. Table 2, there's now 8 people. Table 3, because it's an
It
end
depends
table.
on if we're.
So if it's an end table, it's going to have 10 people. If it's a middle table, it's going to have 8.
Right.
So what we're asking ourselves is how many, we have to have 2 tables with 10. So we're going to have 20 people taken care of on our 2 end tables no matter what. And then we just have to find out how many in between we need to add up
Exactly.
to give us the rest.
Yeah.
So you could almost think of this as an algebra equation. 20 plus 8 per table.
8 per table,
So
yeah.
8x equals how many were we supposed to find out
We
altogether?
need 50.
50.
Yeah, that works.
Yeah.
All right, because we're going to have those 2 end tables regardless. There's going to have to be 2 end tables that will seat 20.
Yes.
And every table in between is going to seat 8.
Yeah. Makes
So
sense.
how many do we need?
Okay.
And since you got it up, I guess you can solve that.
Okay. Well, I like Nate's visual. Let's make that a little bit more clear why this equation works here. So again, he's got, no matter how you set up these hexagon tables, you are going to have the 2 ends, which as you can see on the first one that he has there,
Got 10 here.
there's 10 on an end. So every end you have, there's going to be 10. So 2 ends, 10
So if this
plus
were
10,
an end
20,
table,
that's given.
we would have 10.
Right,
But you notice that we'd only have 28. So
exactly.
this cannot be an end table.
And in all of the middle tables, no matter how many there are, right now he's got it drawn where there's 1 of them,
So if I
there will be
crudely
8. So
another
the
one.
20 people are going to be taken care of no matter what on the end tables. So from the 50 that we have, the 50 people that we have, 20 of them, again, are going to be taken care of by those end tables. So we're left with 30 people to accommodate. So 30 people to accommodate with 8 people at each table, we can take 30 divided by 8 to find out how many tables we would definitely need to seat those 8 people. And it doesn't go into it evenly. We could say, if you said 3 tables, that would only seat 24 people. So we don't want to have people not with seats. So it would probably, in this scenario, be best to overestimate. So instead of saying 3, we would say 4 tables, and that would accommodate them.
And that would give us enough seating for 52 people, which means you'll just have 2 open seats.
Right.
But everybody will get a seat.
So we have 4 of the middle tables that seat 8 people each. So that'll seat 32 people. And then we have 2 end tables that seat 10 people each. So that's 20 people. So altogether, if we had 6 tables, that would effectively seat our 50 people that we need
Right.
to. Now call us back, of course, or send us a message, of course, if that's not the way they were suggesting the tables to be arranged, because as you kind of saw with Nate's drawing, you could probably fit tables elsewhere,
Yeah.
but we're just assuming that they're, lined up that way.
This
so.
seems like the most logical. I mean, even if you were just sitting in like having dinner, you probably wouldn't have
Yeah.
everybody in a big in a big shape.
And you think of the
necessarily.
surface area too of the tables, it wouldn't make sense. It would be a waste of tables if you start
You'd have a bunch of empty
putting
tables
them
in the
all
middle.
together like that.
Yeah.
You'd have a bunch of sides of the tables that you can't sit on.
Right.
So, all right, that was an interesting question. So as you guys can probably see, I mean, we didn't really have that quite figured out by just looking at it.
Right.
We worked our way through it. So that's a part of the problem-solving process.
And again, drawing pictures just helps immensely with these
really
types of problems.
does, really does. And it helped us come up with an equation, helped us look at a pattern, things like that.
Yep.
So we're going to take a break, and we are going to look at a clip. And speaking of how much I like fractions, you're going to get to see me 2 years ago with much shorter hair talking about percents, which are very related to fractions. So
Right.
hopefully you can learn something in this clip.
One thing that I've noticed a lot of middle schoolers and high schoolers struggle with are percents. Percents are actually pretty easy if you think about what the word actually means. If you break down the word, this word per means for each. The word cent, for example, cents in dollars, centipede, means 100, or century. Think about a century has 100 years. So the word percent overall, it means for each 100. So thinking about that in problems such as this, if I needed to find 7% of 200, what that really means is 7 for each 100 that I have. In this case, I have 200. So that means there will be 7 for the first 100 and then 7 for the second 100. So in my head, I can calculate that I've got 2 sevens, which gives me 14. Same idea here. 20% of 400 means 20 for every 100 that I have. In this case, I have 400, so that means I'm going to have 4 20s. And 4 20s together would give you 80. We can also use this idea for parts of numbers, parts of hundreds, such as 50. 50 is half of 100, so that means if I were doing 10 for each 100, I'm going to have half of that if I'm doing 50, because 50 is half of 100. So 10% of 50 is 5. You can do that with numbers like this. 350 is just the same as 350. So if I have 12 for each 100, I have 3 hundreds, so that means I'm going to have 3 12s, plus a half of 100, or half of 12. So 3 12s is going to give you 36, plus that half of the 100, which is going to be 6. So altogether is 42.
So hopefully that helped help you understand percents a little bit better. We were talking about this yesterday. If you caught our show, Sam and I were mentioning that if you understand the vocabulary and understand what some of the terms mean, then you can break down the actual concept a little bit easier, like percents. Percent meaning out of 100. So makes it a little bit easier. So I hear we have a caller. Let's see if we can hear them. Hello?
Hi.
Hello? Oh, hi.
So I have a math question for you guys.
All right.
Okay.
So the question is, a DVD player with a list price of $100 is marked down 30%. If I get an employee discount of 20%, how much do I pay for the DVD?
Okay. Could you repeat the information in that problem one more time?
Yeah.
Please?
So a DVD player has a list price of $100 and is marked 30% off. And then I have an employee discount of 20% off, so how much am I paying?
Okay, so do you want to do this one, or what do you
Yeah, I
think?
mean, I could take this one.
Okay.
So let's just make
I have a
sure.
clarifying question, though, and maybe you do too. The list price is $100, and the 30% off was not already taken?
Yes,
Is that
it was
correct?
not already taken off.
You just
Right.
have 2 separate discounts to do.
Mhm.
Okay.
Yeah, and this is like pretty common in a store for them to
Mm-hmm.
apply a discount and then another discount,
Mhm.
because if you apply them both at the same time, you get more money off.
Right.
So you
So
said
they wouldn't just
originally
say 30% plus 20%. Oh,
exactly,
that's 50%.
because that's half off, right?
That'd be great.
So the DVD player was originally $100, and you got a 30% discount. So a couple ways to think about this. Are you watching right now?
I am.
Okay, so if you see on my screen, I just wrote $100. You could actually calculate 30% of $100 first, and then you get a $30 discount. And then what you end up with is $100, the original price, minus $30. So this is your price after the original discount, right? Another way to do this is to think about, like, if I started at $100 and I get 30% off, then I'm only paying 70% of the price originally.
You should watch our show 5 minutes before you called in, because we were just the understanding percent.
Right. So you kind of get the same thing. You can do this either way. So I'm saying that my list price was $100. Well, if I'm getting 30% off, I'm only paying 70% of the price. Does that make sense?
Uh-huh.
Okay. So my original discount price is going to be $70, but then you're also getting a 30% employee discount, right?
20%.
Oh, 20%. Thanks. So now my discounted price is $70. And then I'm going to get 20% of that. Or if you're getting 20% off, how much are you paying for?
You're paying for 80%.
Right. So it's a little bit quicker to do it that way. So $70 times 80% is $56. Does that make sense?
Yeah.
Yeah. So like we kind of talked about in the beginning, anytime you have kind of stacking discounts, they're going to be one right after the other. Because if we said 30% and 20% off, then you could say $100 times 50%, which would be $50. So you'll see kind of they want you to pay more for what sounds like the same discount.
Mm-hmm.
Does that answer your question?
Yes, it does. Thank you.
All right.
It's
Great.
kind of interesting too. I was working through this as you were talking to her, and thinking, not I wonder if, but wanting to point out that it doesn't really matter which discount you apply first.
Right.
You end up in the same way. So if anybody's interested, you could cut to my screen and see the math on both of them. You still end up, here what I did was applied the 30% discount first, and it was $70. Then I applied the 20% and got to 56, like Nate said. Or you could do, on the bottom, you see where I did the 20% discount first, and you still end up with the same price. So,
Which goes
wish
back
they
to
could
like
do them together.
Yeah, the property where if you multiply in any order, it doesn't really matter. You get
Right.
the same answer. So.
Yep. So, interesting point. All right, let's go back to Lily and get some more of those social media questions.
This one asks, are 9.60 and 9.0800 equivalent decimals?
Ooh, I like decimals too. Do you care if I take this
Go
one?
ahead.
I like
It's kind
decimals.
of related to
and
fractions also.
Okay, so I'm going to make sure I write these down properly, and then we'll talk a little bit about some place value. So the question is, are these two equivalent? And well, and I can definitely see if this maybe they were the same digits, like 6 and 6, 9 and 6, if they were, to see if that was confusing. But these are not equivalent, and I'll explain one of the ways to tell. Here's kind of something that people, or where maybe the confusion really is maybe something like this. 6 and 60 are not equivalent, but 9.6 and 9.60 are equivalent. What we think about when we're measuring equivalency is what place value each of our digits has. So this place value that is right next to the decimal point, right to the right of the decimal point, is the 10th place. So what we're saying is that this is 9 ones, and 6/10. There is still on this decimal, there's still 9 ones and 6/10, and 0 of the next place value, hundredths. Same over here, there are 0 of that next place value, hundredths. We use the 0 as a placeholder. So the place value, where the digit is in the place value, is what determines the value of a number. Zeros, again, are just used as placeholders. When they occur on the end of a number, on either the left or the right end of a number, they don't have to be there. Really where the placeholders are important are when I have something like this, 108. This 0 is holding the place of the tens place. The 1 is in the hundreds. This is saying 100. This is the ones place, 8 ones. But we couldn't really write that like this, or we couldn't write it as 18 like that, because then we're saying there's a 1 in the tens place. So this 0 is acting as a placeholder, and it has to be there. Whereas this 0 over here on the right that I'm going to highlight in a second, this is a placeholder as well, but it doesn't have to be there because, same with this one, there's nothing there. So we also assume that because there's nothing there in that place value, it's also 0. So my tip, I guess, the long story short, whenever you are comparing decimal numbers, I'm just going to get a new section. When we're comparing them, what I like to do is I like to line up the decimal points, meaning I'm also lining up the place values. So you can see that these 9s, those are equivalent. 9s, there's 9 ones in both of these numbers. Here we have 6/10 and 0/10. So different place values. 0 in the hundredths place, 8 in the hundredths place, different. But those are place values, and that basically helps you compare them if you want to line them up. You can also, if there are blanks, like in this spot here, the tenths, hundredths, thousandths, and 10,000ths place, you can also, if you prefer, fill those in with those 0 placeholders. And a lot of times that helps when you're trying to compare numbers and see what's larger. But long story short, no, these two numbers are not equivalent, and that's because of place value. Let's take a little break. Actually, we're going to take a break and let's hear some great information about Emily Griffith High School, and then also another show that we have on our network. So take a listen, take a look.
What is a pun, and why does my teacher tell me to stop using them in my essays?
Is there a formula of sorts for analyzing poetry?
If we had to leave Earth, where should we go?
Subtracting a negative is like adding a positive. So opposite of an opposite. 2 wrongs make a right, I guess.
He went to bed, I went to bed. You wouldn't say, me went to bed, unless you're a caveman.
What is the hottest planet in the solar system?
A semicolon is like Wonder Woman. She can work alone. Coolness, cool points. We'll go
Cool points
there.
count a lot in the universal spectrum.
My grandson has fractions, so here's what the directions say.
Oh, what grade are you in?
4th.
You are very, very smart.
There's times when you wander and ponder all the labels you've received.
Believe me, I've got a few. Never mind from when, why, or how.
'Cause now, everything's different. I found the perfect place.
A space where the labels fade and I'm accepted and supported.
Check what the news reported. Emily Griffith helps all who wish to learn.
Turn towards your future while you finish the basics on your time.
Prime opportunity in this mature environment.
The only requirement is motivation and thirst for success.
Invest in your passions. There's no limit to how far you'll go.
And know that you'll have something in common with everyone here.
We all chose empowerment over standing still in fear.
to Nerd Necessities Network. You're probably thinking, what is Nerd Necessities Network? That's a good question. Nerd Necessities Network is a premier DPS TV show all about nerdy people, places, and things. Check us out on Facebook and YouTube and all the social networks. That's a wrap!
Welcome back. I think we're going to go over to Lily for the Facebook discussion for the week.
So today our Facebook discussion is about Mars and finding out where all the water on Mars happened to go. And recently NASA came up, well, they didn't really come up with a study, they had findings that said that it's actually flying around in the air. And they came up with this from their MAVEN spacecraft, which has been orbiting since last September. And this also adds speculation to if Mars has ever harbored life before. So yeah, it's pretty interesting.
It is I love this topic just because I think we're learning so much about it so quickly recently. And it does seem like the more we study it, the more we're learning that life could actually potentially be supported there. And maybe it was in the past, and maybe it can in the future.
Yeah, and that doesn't mean like aliens like you see on TV.
Right,
it
right,
means
right.
like little, could be little organisms. It could be really
Right.
any like bacteria, something.
Right.
Right?
That the environment is stable for
Some
life.
type of life, yeah.
And currently it's not stable for life. And part of it is due to the atmosphere is essentially not able to protect itself from the sun. And so it's really harsh and cold. But the evidence is saying that it may not have always been that way.
Yeah, I think right now they said the Mars atmosphere is actually about 100 times thinner than Earth's. So all those sun rays are kind of just beating in there.
Yes, so it did. It lost its ability to protect itself from the sun. And that likely happened millions of years ago during some major solar activity. And the strong winds and radiation basically eroded the molecules that are necessary to maintain and preserve the ocean, thus why we don't see water there currently, and the atmosphere.
Yeah, I actually think it's interesting. They actually discovered water on Mars in September. It's like a pretty recent discovery, and it's a huge discovery to happen right now. And kind of just like you said, like opens a lot of doors to what's possible on that planet, as well as other planets we can't even come close to reaching, I think.
And it's so important, and this might be stating the obvious, but because water is so essential to supporting life, this is why this is such an essential and incredible discovery, for sure. Anything else that you found interesting?
Actually, it sounds like we have a caller right now.
We have a caller.
So
All right, so if you want to learn a little bit more about Mars, we do have that article on our Facebook. It's an interesting subject for sure, but let's get our question answered from our caller.
Hi, good afternoon.
Hi. How are you?
Good, good. So I have a math question. It's a problem.
Okay.
So it says, a boat departs from Port Isabel, Texas to an oil rig. The oil rig is 9 miles east and 12 miles north. How many miles is the oil rig from Port Isabel?
Okay, I can take that one. That's actually another geometry question. So if you look at my screen, are you watching right now?
Yes, I am.
Okay, great. So you said we started at Port Isabel. I don't know if I spelled that right. And so the boat departed from here, and it kind of went all the way up here. And again, I'll just draw a little ship here, right, to this oil rig. So
nice picture.
Thank you. I've been working on my ships. You get a lot of these types of problems in geometry, so I've got a lot of practice at it.
I'm impressed.
So you see my ship there?
Yeah.
Okay, so we started at Port Isabel. We went 9 miles east. So, if you think about on a compass, that's going to be to the right. And then you went north, how many miles?
It's 12 miles.
Okay. So this is kind of the distance that was traveled. And you want to find the distance from Port Isabel to that oil rig where the ship is now, right?
Exactly.
Okay, so this is the distance we're looking for. Now, if you're taking geometry, do you know what kind of triangle this looks like right now?
Sorry?
Do you know what kind of triangle this looks like right now?
Yes. Yeah.
What's it look like?
It's a.
I'll help you out. It's a right triangle.
It's a right
Yeah.
triangle.
So I went exactly 9 miles to the east, and then basically took a sharp turn and went exactly 12 miles north, right?
Seems like it would be difficult in a cruise ship, but
Yeah, it might be.
let's
but
not talk logistics.
it's a word problem, so we defy logic sometimes.
Of course.
So we're looking for this distance right here, right?
Mm-hmm.
So what you just need to remember is really what we have is we're solving a right triangle. In this case, our distance is going to be our hypotenuse. And right here, what we kind of drew here, or what I drew here, are the legs of each side. So if you remember Pythagorean Theorem, what we're going to do is, if we call this, I don't know, leg squared, so we're going to do 12 squared. So if you remember Pythagorean Theorem is a squared plus b squared is c squared?
Well, it's been so long ago that I really don't remember well, so.
That's all right. So when we do this, what we're saying is a squared plus b squared is c squared. C is always going to be, in this case, is always going to be our hypotenuse.
Okay.
And these other two variables here are going to be our legs, right?
Okay.
Does that look kind of familiar?
Yes.
Okay. So all we're going to do is it doesn't really matter which one. We can call this 9 miles A. We can call this 12 miles B. And then just to make it a little bit more clear, so it's not confusing, we'll call this distance here C. Does that make sense?
Yes.
Okay. So all we're doing is we're plugging in, we're trying to solve for C. So I know A is 9, so 9 squared. I know B is 12, so 12 squared. And then we're going to say equals C squared. All right, so you see what I'm doing? I'm just kind of substituting the information in there.
Okay.
All right, so now we have 9 squared. And all I'm going to do is simplify this, is 81 plus 12 squared, which is 144, equals C squared. And I'm just going to keep going step by step and simplifying. 81 plus 144 is 225, equals C squared. And then, remember when we're solving equations, we're really just doing inverse operations to isolate the variable we're solving for.
Okay.
So when we look at C squared, the inverse is going to be to find the square root, right? And that's going to cancel out that squared term. Now, remember, if we do one thing to one side of an equation, we have to do it to the other side. So we're also going to have to do the square root of 225. Does that make sense?
Yes.
Okay. So the square root of C squared is simplified to C, and the square root of 225 is 15. So this distance right here from Port Isabel to this oil rig is going to be 15 miles.
Okay.
Right.
Good. Thank you so much.
Does that help?
Yeah, it's enlightening.
All right, great. I'm glad we could help. Thank you for calling.
Thank you so much.
Awesome. Well, let's try to squeeze in one more question. But before we do that, let's hear from Lily and get a repeat of the
trivia question.
You're gonna repeat the trivia question?
Yeah, we're going to repeat that first and then.
Would you like to?
Sure.
All right,
So-
let's repeat that so we can possibly get a winner.
So our trivia question was, after Chinese, what are the world's 3 most commonly spoken languages?
So you want to call in your answer if you think you even have a guess of this one. So phone number's on the top of your
At
screen.
least give it a try. Come on, guys.
Yeah, give it a try.
Yeah, just
I mean,
give it a
there's
guess.
Nothing to lose.
It's not that hard. I mean, popular
right.
languages.
Yeah, jeez. Everybody should know this. Well, in the meantime, while we're waiting for that, let's try to get another question answered from social media.
So this one asks, Jasmine has a bag of marbles. She has 7 blue, 21 green, 17 red, 37 white. What are the odds that Aladdin will draw a blue marble first and a white marble second?
Okay, and a white marble second. So I'm going to make this explanation relatively quick because of the time we have left. So if you have further questions about probability, let me know. But if you're studying probability, one of the things that you should probably know is that when you're finding the odds of something, you're putting it in a fraction, considering on the top is the probability of whatever, we actually kind of write it this way. We say P of what you're talking about. So in this case, we were wondering about the blue, and then the probability of, or the number of the total, or the probability of the total. And so when we're doing that, so if we wanted to find the probability of the blue marbles, we're going to do 7, because there's 7 blue marbles, and then over the total amount of marbles, which when you add all of those numbers together, you get 82. So the probability of choosing a blue marble is 7, while when you, we also wanted to know about the white marbles. And when we do probability of events that occur consecutively, you multiply the two probabilities together, and that'll give you the probability of those two events occurring consecutively. Again, if you have further questions about that, I'm willing to follow up for sure, but as for time, I'm not going to explain why that is. So probability of blue is 7 out of 82. The probability for white is 37 out of, again, our total, which is 82. And then to find the probability of both of those events occurring consecutively, we're going to multiply those. And so 7 times 37 is going to give us a numerator of 259. And then 82 times 82 is going to give us a denominator of 6,724, which, you know, you could leave your answer this way, but that doesn't really mean all that much. What I like to do is convert it to a percent. When I'm thinking about probability, it means a lot more to me anyways. So to convert it to a percent, you would just divide the numerator by the denominator, and when you do that, actually that gives you a decimal, which is 0.385 about. And then to take that to a percent, we'll just move our decimal 2 spots over. So that gives us about 3.85% of a probability that this will occur. First a blue and then a white. Or white and then blue. It could be that as well.
Not very likely.
Not very likely. Consecutive events are not very likely because you're thinking of, well, first it's a small probability that we're going to pick a blue one anyways. And then to also pick a white would be difficult as well, or not a high probability as well, and then to do them together, very low probability. So.
Right.
All right, we have a caller for our trivia answer. So let's see if you got the question right. Hello?
Hello?
Hi.
All right, so I'm going to guess that the languages are English and Spanish, and I think French.
Oh, you are so close. You got 2 out of our 3 common
Do I get a
languages.
consolation prize for 2 out of 3?
We could figure something out for you, I'm sure. Absolutely, because you know what? We're thankful that you called, and plus that's 2/3. That's more than halfway right. I'd say so. So let's actually get the real answer from Lily. What's the third one?
So the third one is Hindi.
So you were right on the English and the Spanish. But that third one is Hindi.
Yeah, they should put Hindi in high school classes because that would have been easier to guess.
Yeah,
that's true. That would have I see where your guess came from for sure.
Yeah.
Well, thank you for calling. Too. Stay on the line and we can arrange some kind of consolation prize. All right, thank you. So we got our trivia question answer. Let's talk about that actually a little bit.
Yeah, I didn't realize Hindi was one of the most common, but it actually makes sense because there are about 1.2 billion people in India, so that's a lot of people that speak that language.
Which, you know, and this is also why Chinese is the top spoken language in the world, because China is very very heavily populated as well. So what languages did you guys guess?
I guessed pretty much the same, but I mean, I was kind of going with French too, to be honest, because French is pretty popular. I mean,
And maybe because it's what's taught in schools,
Yeah,
right? Spanish,
exactly.
French
That's
are usually pretty common.
I did think English and Spanish, but I was thinking it was going to be some sort of trick question, like some sort of dialect of Chinese is what
Because
I was
there's so
thinking.
many. Yeah.
Which actually brings us to kind of an interesting point. Accent versus dialect. Do you know the difference?
I think accent's kind of just like how you say things, and dialect is kind of it's almost a different language, right? Different structure
You're
of
so
language.
right about that. Accent is the way that you say something, so just the way that you're pronouncing something. And then the dialect is like actually a variation in the language itself. So maybe using a different word for something else. So it is a type of a language that is derived from a primary language. And what I'm thinking of right now is Italian and then Southern, like Sicilian Italian. It's very difficult to understand one if you know the other and vice versa.
Yeah, I tried taking Chinese when I was in middle school, and it was incredibly hard because my aunt lives in Beijing, and so I was like, oh, I want to learn so I can go visit her, but I never ended up visiting because I only could get past ni hao, and that's about it. So
you tried to learn Mandarin? Chinese,
yeah,
that
Mandarin.
dialect?
Yeah, and it was real. I couldn't get past like the numbers were what got to me, and I even have a problem with Spanish numbers. And my family's from Mexico, so don't give yourself a hard time if you have trouble speaking Spanish. I have a trouble speaking Spanish, and my family make fun of me all the time. So
languages are difficult.
I just
so many
speak
rules.
English or sarcasm, so they go hand in hand with me. So
Is that a dialect?
Or sarcasm?
Sarcasm
must
is a
be.
dialect?
It must be a dialect.
I would
of
consider
English.
it. I mean, I use
For
it
Louis
quite
it
often.
is.
Yeah,
Right.
pretty much.
Well, very, very interesting.
I don't know, some languages are a little easier to pick up because the structure grammatically is the same. It's just learning a lot of different vocabulary.
I've heard German is relatively, the structure of it is
because they
similar
have
to
like so many
English.
meetings for one word, and
Yeah.
All
Japanese is actually a similar structure. Alphabet's not too big either, so.
yeah.
Very interesting.
All right.
All right.
I think we got time to do a quick math shortcut.
Ooh,
If you
go
want to
for
do,
it.
I'm just trying to think of one off the top of my head. I think like multiplying numbers, kind of bigger numbers, is challenging a lot of times. So like, if we do like 20 times 26, for example, and I think we kind of talked about this before.
Oh, we did. We were talking about mental math and.
Yeah, and you're kind of just breaking stuff down. So if you wanted to do 20 times 26, it might be a little bit more challenging, but there are a couple ways you could think about this. Like if I did 20 times 25, that's pretty easy to do.
Oh,
right?
is it?
I think so.
How's it easy? What's going on in your head?
That's a good
that's
question.
Easy?
So I would just do.
I mean, I think it's easy too, but.
Yeah. You know,
we do this a
25
lot.
times 2 is 50, and then just add the 0 on the end. So you'd have 500.
Yeah.
Right? You could also think of it in terms of money, right? 25 quarters is about $5. But then keeping in mind, like, we're not multiplying 20 by 25, we're doing 20 times 26. So there's really just one more 25. So it would be, one more 20.
Yeah.
It's not a shortcut if you make a mistake. Right, so it'd be 520. So these are some ways to just kind of quickly just break things down into math that's a little bit simpler.
Yeah, thinking of things as groups of numbers.
Exactly, that's a good way of saying it, groups of numbers.
Very true. Yeah. Well, we're out of time, so if you want some more tricks and mental math help, you can see us next week from 4:30 to 5:30 on Monday and Tuesday. We'll be here live to answer your questions.
Yeah.